Well, in the first part of the section 6.1, we talked about the notion of probability and statistical inference. Now, in the second part here, let's talk about what we mean by a probability experiment. We can define a probability experiment as a process that leads to well-defined results called outcomes. And we see here in slide number 7 the two conditions that must be satisfied for an experiment to be a probability experiment. The first is the outcomes must be unambiguous, meaning that the outcome of an experiment has to be empirical. In other words, we have to be able to see the results, and it can't be wishy-washy as far as what the outcomes are. We have to be able to write it down with certainty what the outcome is for a specific experiment. And then the second condition is that all the possible outcomes have to be predictable, but on any given trial, the outcome cannot be predicted with certainty. In other words, there has to be somewhat of an element of uncertainty about it for an experiment to be a probability experiment. All right, well, let's take a look at an example and see if we can classify experiments as probability experiments here. So in example 2 on slide number 8, let's try this. Let's determine whether the process represents a probability experiment. So in part A here, it says the suggestions card at Pappy's restaurant asks for customers to rate the service as fair, good, or excellent, and then rate the quality of food on a scale from 1 to 5, with 1 being superior and 5 being lousy. Well, let's see here. Let's think about the solution for this now. So for example 2, let's see. The outcomes are clear. They were to rate the service. Let's just look at that again as fair, good, or excellent. Fair, good, or excellent. So when you look at the data that would come out of this experiment, notice here it would be one of these 3 words, which is a form of data that we can talk about later. It's called nominal level data. And then the food was rated from 1 to 5. So in other words, these rankings of the food are they're uncertain because different people have different tastes, but it's clear that one of the answers is going to be one of these digits 1 through 5. So this is a probability experiment. All right. So part A is a probability experiment. Now let's move to slide number 9 here and take a look at part B. And we want to determine if this process represents a probability experiment. A random sample of 1,050 people were asked, if you could change your name, what would you change it to? If you could change your name, what would you change it to? Well, it looks here that in part B, that the outcomes are not predictable. I mean, you could change your name to anything, and you can't write them all down in advance. That wouldn't be practical. That's called the sample space to write all the possible outcomes. And so in this case, the process is not a probability experiment. All right. So we talked about the difference between a probability experiment and not. And then we talked about this notion of statistical inference. And now, in slide number 10, let's take a look at another type of piece of information that we'll need for later on. The difference between an ordered and an unordered sample. Now, by a sample, by the order being important, we mean that one of two things. The order or arrangement makes a difference, or there is a ranking involved of the members of that arrangement. So if there's a ranking involved, or the order makes a difference, there's a distinction, we say their order is important. Otherwise, we just simply say order is not important. All right, so let's take a look at an example of one of these now. So in slide number 11, let's see if order is important here. In part A, it says the chess club at Dyston High School has 15 members. When computing, how many ways can a president, a vice president, a treasurer be selected? In other words, is order important here? So notice in this case, in example 3, part A, there is a ranking. That would be the president, the vice president, the treasurer, and so on. So order is important. All right. So that's part A. Now in slide number 12, let's take a look at part B here. It says the central office at Higgins Corporation has to choose 3 of 8 regional offices for an audit. When computing how many ways the regional offices can be chosen, is order important? So let's see here. Here we have 8 of these regional offices. Eight offices. And we want to choose 3 to visit. And so here it looks like it doesn't matter which 3 it is. They're certainly not ranked where one is the best, one is the worst, that kind of thing. So in this case, order is not important. All right, so there we've learned the distinction between order being important and it not. And then we talked about what it means for an experiment to be